In this video, we're going to talk about dplyr's functionality for row manipulation. We're going to start with this tibble, and this is going to be our running example for this entire video. It's just a simple tibble. It's called TB. It has 3 columns, X, Y, and C. X and Y are both numeric, and C is a character vector. So when it prints out, it looks like this. 5 rows, 3 columns. The first major verb in dplyr is filter. Filter is roughly equivalent to base's subset function, and its purpose is to keep qualifying observations. So it's going to throw away or discard rows that don't satisfy a particular condition. For example, here if we say TB filter C equals A, it's going to pull out all of the observations in the data set where C is equal to A. So the result, of course, looks like this. Now, subset in base R at this level works identically. You wouldn't use piping, of course, but the same basic idea applies. If you were just using row subsetting, you'd have to do something like this, which is obviously a lot more clunky. What this does is it creates a logical vector, and then it subsets that tibble as a data frame by the logical vector by rows. It's a very natural operation, but especially if the name of the data set is long, or if you want to chain some of these commands together, it gets really cumbersome to subset things like that. In addition to subsetting just with one variable, you can actually subset based on many conditions just by putting commas between them. So here I'm saying take the tibble TB and filter out all the rows where C is equal to A and X is greater than 1. The result, of course, is this tibble. Now think about how you would do that if you were using ordinary row subsetting using logical vectors. You would actually have to dereference the tibble twice, and then you would conjoin those with an ampersand. I think that it helps to kind of take a step back at this point and just look syntactically at the difference between these two calls. Ultimately, they're resulting in the exact same tibble, but one is just so much cleaner and so much more expressive than the other one that it really highlights the benefits of using the tidyverse. So filter is the first verb. It's a major verb. It's very important. The next major function is arrange. Arrange's purpose is to put the rows of a tibble or a data frame in order, to sort them, okay? So if this data frame is on the top right, we're going to sort this by the Y column. So TB piped into arrange by Y. So sort the columns in order of the Y variable. In this case, it's just going to take that last row and it's going to move it up to the second row of the data frame. And that's going to sort the data set in so-called ascending order by Y. In other words, Y goes from being small to being big. Now, if we wanted to sort it the other way in so-called descending order, we could have typed in TB piped into arrange minus Y. So sort it in ascending order by minus Y. That would actually work for numeric Ys, but it wouldn't work if Y was a factor or if it's a date. In those cases, you're going to want to use this DESC or descending column. So TB piped into a range of des Y. Now, one of the nice features of arrange is that if more than one argument is listed, it will actually do the sorting, but it will break ties in the first arguments by whatever comes after it. For example, if I take my tibble and I arrange by Y, notice that there are 2 Ys that have Y equal to 1. There's this Y and there's this Y. Or in the original sorting, there was this Y and this Y. Now, by default, it is not going to break those ties. So what's going to happen is when you sort by Y, it will keep the rows in order that they just appeared naturally in the data set. So for example, in this case, this row just came first, and that's why it's first. This row came second, and that's why it's second. If you wanted to sort the rows within the ties, here the ties, of course, Y equals 1. If you want to sort the rows within the ties, that's when you put other arguments after the original variable you want to sort by. You can do this as many times as you want, and it will sort those in the exact same way. So here I say descending X, so it sorts it in descending X. And the result, of course, is that those rows have been swapped. Next is count and add count. Count, which is the more important of the two verbs, counts the number of occurrences of a particular level of a variable. It's useful when you're doing things like determining or cleaning all codings of a variable. For example, when you're trying to clean a data set and you're looking at a categorical variable or some kind of basic response variable, yes or no or something like that, it's very common that people will do little things that make them a little bit different. For example, maybe they'll capitalize the Y or maybe they won't. Or they'll capitalize the N or maybe they won't. It's useful to tabulate the levels of a variable in a data set to see kind of if you've gotten them all. And count is great for that kind of thing. It's very much like the base function table, but in this kind of tibble, tidyverse way of doing things. So the basic syntax would look something like this. Take TB and count C's. So count the C variable, okay? Notice the components of this. In the top right up here, we're saying count the variable C. And so we get a tibble back, and its first column has C in it, and that column has the levels of the categorical variable C. In other words, all of the possible instances, all the values that C took on. The second one is called N, and N, of course, is just the number of times that each of those levels was observed. If you use add count, it will do effectively the same thing, but instead of reducing the tibble, it will just add a new column to the tibble that you put in, and the new column tells you the number of times that that thing was observed. And again, it's called N. One of the other nice features of count is that you can actually give it an expression to evaluate, and then it will tabulate the results of that. So here's an example of that. TB piped into count x is less than 2. So the idea is that you're trying to count the number of times that the x variable is less than 2. So that's kind of an expression that has to be computed on the fly. It's either true or false, and the result looks like this. Now the oddity here is that you have this kind of non-syntactic name of the resulting tibble, and of course that comes straight from the expression itself. So there were 4 rows, 4 observations where x was not less than 2, and 1 where it was. Okay? We can make that call a little bit cleaner if we actually associate a name to the expression. Okay? So here, instead of just having the expression, I say small x is equal to x is less than 2, and the resulting name of the tibble is small x. Now, count can also be used with more than one variable, but to do this in a kind of meaningful way, I need to actually add a row to the tibble. So my tibble right now doesn't have any duplicated rows, and I'd like to create one. So I'm going to use the add row function to just add a row at the bottom of the tibble. Here my new row is just x is equal to 1, y is equal to 1, and c is equal to a. Those are those rows in the top right that I just added. Those are duplicated. And if I wanted to use the count function, I can count by both the x and the y variables. What this is going to do is it's going to take all of the possible combinations of the levels of the x and y variables, and it's going to count the number of times that those actually occurred. In this particular case, since I added a row, there's one row that has been duplicated exactly once, and that is that first and last row. So I say count of x, y, and then notice that I have x is 1, y is 1, n is 2, and that's because that's the duplicated row. Now, kind of analogous or corresponding to this, you also have a function called distinct, which is in dplyr. And distinct is going to discard or dedupe all of the duplicated rows in the data set. Okay, it's going to remove the duplicated rows in the data set. We know here that we have 1 because we just counted them up. So if I use distinct on the output, here it removes that last row, and now all of the rows of the data set are unique. Distinct will also accept variable bindings. Since I actually didn't say x or y here, it actually did it for all the values, but you can also just pass in like an x or xy, and it will dedupe based on those variables. Next, and very importantly, in row manipulation in dplyr is slice and its variance. Okay, so really when I think about what are the major row manipulation functions in dplyr, I usually think of filter and slice. One of the really nice parts about version 1.0.0 is that slice is getting a lot of variance that systematize a lot of the older framework. Now, slicing is really important. So what is slicing, right? Slicing a data set refers to extracting rows of the data set, typically by index. So at a basic level, it's just going to replace the single hard brace operator when you're subsetting matrix style. Okay, so TB piped into slice 2.4 is just saying, give me the second and fourth rows of the data set. So nothing really tricky here. It's identical to this call. Of course, I can put in negative integer vectors as well, and it will just remove those from the data set. So again, nothing really new here. It's a little bit more tidyverse style in terms of it uses piping and that kind of thing, but it's not really giving you anything new at a basic level. Our first kind of getting something new comes in slice sample. So slice sample is a slice variant, so it's going to give you some of the rows of the tibble, and its role is going to be to subsample the rows of the tibble. So if I say TB slice sample prop equals 60, it's saying, give me 60% of the rows of the tibble. Now, by default, those are sampled without replacement. If I want them with replacement, I would say replace equals true, and then I get them with replacement, and of course I can see the same row multiple times. Now, in a case where your data set is not evenly divisible in the way that you request, so for example, in this case, I have 5 rows, and I'm asking for 50% of the data set. What slice sample is going to do is it's going to round down. Now, the previous implementation of this was called sample_frac, and that is actually still in dplyr, but it's going to be superseded by the slice sample function. What's nice about slice sample is, one, it's called slice, so you know it's pulling out rows, And two, you can either sample by proportion, I want 50% of the data set, or you can sample by the number of observations that you want. So you would say take TB, slice, sample, n equals 3, give me 3 rows from that data set. Again, those are generated with simple random sampling without replacement. If you want it with replacement, of course you just say replace equals true. Slice min and slice max are going to give you back the rows of the data set that correspond to the smallest or largest rows according to a particular variable. For example, TB slice min x n equals 2 says, give me the 2 rows where the x value is the smallest. Okay? And of course you have it on the other side as well. TB slice max x n equals 2 gives you the 2 rows where x is the largest in the data set. Now, consistent with slice sample, you can also say TB slice min x prop equals 40. Now, what's going on here is you're asking for the lowest 40% of the rows as far as x is concerned. In other words, you want the rows of the data set that are at or below the 40th percentile according to their x value. Now, currently there is a bug in the corresponding function slice max, but I would expect this to be fixed before version 1.0.0 ships. So I would expect slice max to behave in exactly the same way. Now, the previous functions that this replaces are called top in and top frac. Top in worked like this. You would say TB top in 2x. So the first value, this is a little weird, the first value is the number of rows that you want. That's not very strange. But the second one is the variable that you want to sort the data set by. And that is a little bit odd because none of the other dplyr functions work like that. With all the other dplyr functions, you take the data set, you pipe it into a function, and then usually the first arguments of that function are variable names unquoted. So it's strange in this case to actually get a number coming first. Now, notice one other aspect of this, and that is that the rows in this case come back 4, 5 in the x value instead of 5, 4. In other words, the top n function that is now superseded did not sort the ultimate rows that you got back. It would just give you those rows that corresponded to the top 2 values, but it wouldn't actually sort them. And that's a little odd, but that's just how it did things. The bigger oddity was that there was not a corresponding bottom n to go with top n. So if you wanted to have the 2 rows of the data set that corresponded to the 2 smallest values of x, what you would actually have to do is say TB top n minus 2. So, kind of start at the bottom and give me those minus 2. It was just odd, and the new implementation is significantly better. Now, let me warn you about something else as well. If you set n equals 2, you won't necessarily get 2 rows back in the event that there are ties in that variable. Here's an example. If you take the tibble and you slice min by y now instead of by x, notice that there are ties. The first row and the last row both have y is equal to 1. By default, what will happen when you use slice min in this circumstance is you will get both rows back. If you don't want to get more than the number of rows that you ask for back, you can actually just change a default value in the slice min function, and it will turn that off and it will just give you the first rows that actually match that criterion. But again, by default, you're getting that with ties equals true functionality. The next slice variants are slice head and slice tail, and they do exactly what you would think with head and tail from base R. The difference is that slice head and slice tail are going to give you expanded functionality in terms of proportions. Now the base functionality is the same. So if you say TB slice head 2, give me the first 2 rows of the data set. Slice tail, give me the last 2 rows of the data set. TB slice head prop equals 40 says give me the first 40% of the data set by rows. And of course, you can also do this by slice tail. The last function that we want to talk about in row manipulation is n. N is kind of the simplest and the strangest of the functions that we have talked about in this video. N is a context-dependent expression that refers to the number of rows of the tibble at that point in the computation. Okay? It's only used inside of other tidyverse verbs. So usually you will be using this within other dplyr calls. You would never use this kind of at the top level at the console itself. Let's see an example. If I say TB slice n, I'm saying give me the last row of the dataset TB. Now, of course, in this case, we know that that last row is 5 because we know that it has 5 rows. Nevertheless, this is how this works. Here I have TB slice 4 to n. So take the 4th row to the nth row. Again, here I know it's 5, but we're going to find ourselves in situations where we don't know what that last row is. And that almost always happens because of something like grouping. Here's our first example of grouping that illustrates more complex behavior made possible by n that is not clear how you would do this in another context. So take the tibble TB, group its rows by their C values, and then select the last row. In this case, when it does the grouping, it groups the levels of C as A and B, and then those are going to be the last rows in those data sets. The ability to group is going to allow us to be much more expressive about our computations on data frames. So we're going to have an entire video just dealing with grouping, and that's coming next.